The term cold is often used to describe a subjective feeling of discomfort caused by exposure to low temperatures. However, from a scientific perspective, cold refers to a state of low thermal energy, which can be measured in units of temperature, such as degrees Celsius or Fahrenheit. One of the most important concepts related to cold is thermal conductivity. Thermal conductivity is a measure of how easily heat can flow through a material. Materials with high thermal conductivity, such as metals, are good conductors of heat, while materials with low thermal conductivity, such as air or insulation, are poor conductors of heat. Another important concept related to cold is phase transitions. Phase transitions occur when a material changes from one phase, or state of matter, to another. For example, water can change from a liquid phase to a solid phase. Ice, at a certain temperature, known as the freezing point. When a substance changes phase, it either absorbs or releases thermal energy, which can affect its temperature. Cold temperatures can have a variety of effects on living organisms. In humans, exposure to cold temperatures can cause vasoconstriction, which is the narrowing of blood vessels in the skin and extremities. This can lead to decreased blood flow and heat loss, and can even result in frostbite or hypothermia if the exposure is prolonged. In the natural world, cold temperatures can have a significant impact on ecosystems. For example, in colder regions, many plants and animals have adapted to survive in low temperatures, such as by growing thick fur or hibernating during the winter. Finally, it's worth noting that the perception of cold can vary greatly between individuals and cultures. What feels cold to one person may not feel as cold to another, and different cultures may have different attitudes toward cold temperatures. Here are a few more interesting facts and concepts related to the science of cold. The coldest naturally occurring temperature ever recorded on Earth was -128.6 degrees Fahrenheit, -89.2 degrees Celsius, which was measured at the Soviet Union's Vostok station in Antarctica in 1983. However, scientists have been able to create even colder temperatures in laboratory settings using techniques such as laser cooling and evaporative cooling. The study of cold temperatures and their effects on materials is important in fields such as materials science and engineering. For example, materials used in aircraft or spacecraft must be able to withstand extremely low temperatures at high altitudes. Cold temperatures can also affect the behavior of gases. At low enough temperatures, some gases can condense into liquids or even solids. This phenomenon is known as liquefaction or solidification and is used in processes such as the production of liquid oxygen and nitrogen. Many organisms, such as certain species of fish and insects, can survive in extremely cold temperatures by producing natural antifreeze compounds in their bodies. These compounds help to protect the organism's cells from damage caused by ice formation. Cold temperatures can also have psychological effects on humans. For example, some studies have suggested that exposure to cold temperatures can increase feelings of loneliness and social isolation. The coldest known natural substance in the universe is a cloud of gas and dust located in the Boomerang Nebula, which has a temperature of approximately 1 Kelvin, -272.15 degrees Celsius. The temperature at which water freezes is affected by factors such as pressure and impurities in the water. For example, water can remain liquid at temperatures below freezing if the pressure is high enough, as is the case with the water in the deep ocean. Cryogenics is the study of materials at very low temperatures. Cryogenic temperatures are typically below -150 degrees Celsius and are used in applications such as the storage and transportation of biological samples and the cooling of superconducting materials. The study of cold temperatures is important in a variety of fields, including medicine, where it is used in treatments such as cryotherapy and the preservation of organs for transplant, and in the food industry, where it is used in processes such as freezing and refrigeration. Finally, the perception of cold can be affected by a variety of factors, such as humidity and wind speed. The wind chill factor, for example, is a measure of how cold the air feels on the skin due to the combined effects of temperature and wind speed. The concept of absolute zero, or the temperature at which all molecular motion stops, is minus 273.15 degrees Celsius or 0 Kelvin. Absolute zero is purely theoretical and has never been achieved, but scientists have been able to cool certain materials to within a few billionths of a degree above absolute zero. Cold temperatures can have a profound impact on the behavior of gases. For example, at temperatures approaching absolute zero, helium can become a superfluid, which is a fluid with zero viscosity and the ability to flow without any resistance. Cold temperatures can also affect the behavior of materials at the nanoscale. For example, some materials exhibit unique properties, such as superconductivity and magnetism, at low temperatures. These materials are used in a variety of applications, such as in high-speed trains and MRI machines. The study of cryobiology is focused on understanding the effects of cold temperatures on living organisms. Cryobiology is important in fields such as biotechnology, where it is used in the preservation and storage of biological materials, and in medicine, where it is used in treatments such as cryosurgery. Finally, cold temperatures can have a significant impact on the environment. For example, melting polar ice caps due to rising global temperatures can have far-reaching consequences, such as changes in ocean currents and rising sea levels. Overall, the science of cold is a fascinating and important topic with many different applications and effects. I hope this information has helped increase your understanding of the subject. If you have any further questions, feel free to ask.